Third session of the series concerning upgrading from legacy to the cloud with Scribd. Today's session is actually going to be focusing on moving ad hoc users to the cloud. My name is Denny Lee. I'm your host for today's session. I'm a developer advocate at Databricks. Prior to this, I used to be at Microsoft. I happen to also worked on the Project Isotope, where we moved our big data platform to get Hadoop on Windows and Azure. Why do I bring that up? Because today's session, like the other two sessions, were about how we migrated, or in this case, how Scribd migrated from legacy to the cloud. So without further ado, let me dive into some introductions. So let's start off with our familiar face. I believe you've seen him in the other two sessions. Alex, why don't you start by introducing yourself?
Hey guys, I'm Alex. I'm a data architect here at Scribd, and I also am a tech lead of a data engineering team. I'm going to give you a little bit more history of myself than I did in the prior two sessions. Like a true high-quality data engineer, my first software engineering job was writing reports in Microsoft Access. So this is where I started and slowly moved my way up. At some point, they let me touch a real database, which was Microsoft SQL Server. And believe it or not, my first cloud was Azure, and HD Insights was my first big data platform that I got my hands on. So, Denny, there you go. It all comes back here.
I'm so sorry. My apologies. Yes, it's like the other Bart meme. No, Excel is not a database, and for that matter, nor is Access. Okay, nevertheless, let's continue the introductions. Tyler, you're up next, and you're also a familiar face, so to speak.
Sure, let's go with that. So I'm R. Tyler Croy, excuse me. I'm the Director of Platform Engineering here at Scribd. So I lead the core platform team, which manages a lot of the data platform infrastructure that we have, the data engineering team, and the data operations team.
Thanks very much. That's fine. That's fine. Thanks very much, Tyler. I hope you start remembering your last name. But nevertheless, third. Yeah, I know those 4 letters, man. All right, let's dive in. Hamilton, without further ado, you're last, but you're certainly not least. Why don't you introduce yourself, Hamilton?
Sure. My name is Hamilton. I am a site reliability engineer for the core platforms team, working closely with Alex on setting up all of our sort of infrastructure needs for all of our platforms.
Hamilton, thank you very. Oh, sorry. Go ahead, please.
And a fun fact about me, I learned a lot of my chops about big data from my time over at Blizzard Entertainment.
Oh, that sounds pretty cool. Actually, that could be its own recording session, but let's not digress too much. Alex, why don't we start by reminding some of the viewers here a little bit about the legacy migration to the cloud and moving batch jobs to the cloud as part of the previous 2 sessions. Just to remind viewers what it took for you to go from your on-prem systems to the cloud that you're currently working with right now.
Sure. In our previous couple sessions, we initially covered how we set up a data synchronization between our on-premise system and our new AWS infrastructure. After that was done, before we could take on migration of our almost 1,500 jobs and pipelines, we actually had to set up our ad hoc users and our developers in the new environments so that this migration could have actually happened. So I know we're doing this thing this session last, but actually this is something that happened before we were able to migrate all of our batch workloads into the new environment.
That is absolutely awesome. So now that we have that little bit of context, and normally Alex would also be chiming in saying, and I'll do it in his case, which is really, if you want to know more, watch the previous 2 videos. Let's go ahead and switch to over. Today's session is really about, now that we've, in the previous 2 sessions, we've talked about moving the legacy environments and batch jobs to the cloud. Now we actually want to discuss a little bit about moving ad hoc users to the cloud. And there's a lot of really interesting things, like whether it's the exploratory non-developer use cases, how Scribd move development into the cloud, model training use cases, and shared cluster resources. So In order for us to kickstart it, I'm going to just go through each of these 4 themes, and then Tyler, maybe I'll start with you a little bit about the exploratory non-development use cases, since I think that's a good way to start off.
Sure. One of the things that I like to point out with folks when we talk about the data use cases at Scribd is that data is sort of key to what makes Scribd as a business work. You know, if you've ever worked with Scribd or seen Scribd in the wild, there's user uploaded documents, there's books, there's an incredible amount of content. And as such, we do a lot of interesting and novel things with that content. So data and access to data is a pretty key aspect for a lot of people's jobs at Scribd. When we were in I'll start with the on-premise, our legacy setup and what that entailed for people. You know, in the classic Hadoop environment, pretty much all we could offer people at the time was, you know, access to Spark shells, which Alex will talk a little bit about later, or for most of the people who wouldn't have called themselves a developer, access to Hue, you know, which is basically like PHP MyAdmin on top of Hive. And for a lot of people, what ended up happening was data was impenetrable. So we had, at the time, our now called applied research team, then it was just called the data team, would end up servicing a lot of requests from people around the organization for like, I need to know answers to this question with data, but I don't know how to get that data. I don't know where to get that data. I don't know what tables that might exist in. I don't have the wherewithal to start there. So please just go find my answer for me, which, as you might expect, is a very, very inefficient way of doing things. We also had Tableau running around, but Tableau is just as impenetrable for a number of people as Hue was. So we don't need to talk about that either. What ended up happening, which was really fascinating to me to see, is once we opened up, like, you know, moving our data, as Alex referred to in previous sessions, setting up that data sync actually allowed people to go start explore data and experiment with data in our data warehouse or the user-generated content that we have stored in S3 in ways that we didn't actually expect. Probably my favorite use case that I've seen that, you know, we actually didn't account for previously at all is developers or product managers setting up notebooks while they're developing a feature that they're then going to run immediately after they deploy something. So they can actually create these notebooks that define their acceptance criteria. And once something is shipped, then they're just going and, you know, once data starts flowing in, whether that's through batch workloads or streaming workloads, then they're just running, you know, did this feature work? Notebook. The other so let me step back and mention one of the things that we did when we moved to the cloud, and I spoke about this in my Spark and AI Summit talk in 2020, was we set up a lot of streaming workloads into our data platform, which is something that we genuinely could not have done without some of the tooling for Spark streaming jobs in Databricks and Delta Lake. Huge fans of Delta Lake here. Can't tell you enough about Delta Lake. But so all of a sudden, our ad hoc users and these people, like, say, product managers, started to get access to streaming workloads, which meant that instead of waiting for answers till tomorrow after the batch that we've talked about previously has run, they would be checking in on things within a couple minutes, maybe, you know, no greater than 2 or 3 minutes. They would be getting data that they could work with. And once we started to have that data available, I was blown away when I saw this, because I didn't even think about it. I saw developers as well using notebooks and querying our data to do production incident triage, which was something that was like galaxy brain. Like, I was so amazed when I saw it, because what ended up happening is we had this live incident where we had to find, you know, some cohort of users were experiencing this bug and whatever. And one of the engineering leads that was working on the project, because data was streamed and because they could go explore all of the data that we have in our warehouse very effectively, they were pulling together all of this data in one notebook to identify who are the users that were affected, how were they affected, and actually helped in a lot of ways identifying what the underlying bug was. And all of that sort of, this sort of like amazing secondary benefits that we realized by moving this ad hoc workloads into the cloud strictly came, in my opinion, from making data accessible and easy for people to discover, and then letting them figure out what they want to do with it. And for me, that was like, it's difficult for me to imagine at this point how we would figure things out without this level of access or understanding to data, not just within engineering, but also across, marketing teams or product teams or our content operations teams. Like, the Pandora's box has been open. Like everybody is already benefiting from all of this data, where they pretty much before had to go to individuals in the office. These were the olden times, and say, I need a question answered, please. Can you go consult with the data and then come back to me? Now people are just sort of self-service and going and figuring out what they need to figure out to do their jobs, which is fantastic.
Oh, that's awesome. And for everybody that's wondering, I did not pay Tyler to talk about Delta the way he does, so even though I talk about it all the time. So one thing I did want to focus a little bit about that you sort of alluded to, but I wanted to bring to the forefront, and with Tyler, whether you want to go into it or Hamilton, you want to go into it, let's talk a little bit about like those streaming use cases, and also about like the ability to work with logs. I mean, you've talked about that use case where, in essence, your product managers are actually using the data to understand the features. That's great, but then there seems to be that implication that they're able to build those notebooks and start accessing the data mainly because they actually had immediate fidelity or immediate access to the data. So why don't we talk a little bit about that from that perspective?
Yeah, this actually comes down to some of the roadmap that Core Platform as a team was working on in 2020. Like, we really wanted to try to make as many data sets that were available as streams, or produced as streams, I should say, available as streams. So in the before times, we had like data would flow into Kafka, and then Hamilton, I think we were just, was it Flume touching things once a day? I don't actually remember how Flume worked.
Flume would occasionally batch files into HDFS, and then one of the first tasks that would kick off on the nightly run would taking that data and putting that into Hive, to where it's then accessible by the rest of the batch jobs. So even the most rawest of data wouldn't be available until the nightly started kicking off, even though it's written relatively often.
Yeah, and when I came to the organization, it was actually really funny to have this discussion with folks of like, hey, what if we gave you data that was streamed? And some engineering managers would be like, oh, we're actually already writing that to Kafka. I'm like, okay, and then what happens? Well, then we see it tomorrow. It's like, wait, what? This doesn't make any sense. So we were like, some of the foundational work that Core Platform needed to do was take data that was actually already available as a stream and wire that into Delta Lake and make that available. One of the things, and this is something I talked about in my Spark and AI Summit last year, go see it, blah, 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 like and subscribe, etc. But one of the things that was really transformative for us with Delta Lake is we were able to bring the streaming data into effectively the same quote unquote location as everything else. So Hamilton mentioned that, data would come into HDFS, and then we would do this processing step into Hive, right? With Delta Lake, and why these streams are so powerful for our ad hoc users is because we're basically streaming right into the table. So if somebody needs, let's say product manager Denny needs to ask a question of data that is over the last 24 hours, or even over the last 6 hours, he goes to, I'll just use this table name. It's not super secret, but logs.fastly. We'll just go to my favorite data set, logs.fastly. Denny can query that over the last 6 hours and get an answer. But naturally, what's likely going to happen with most exploratory use cases, if you see something anomalous, say in our production incident response scenario, you're going to say, well, this happened over the last 6 hours. What did it look like yesterday? Or what did it look like a week ago? And because we have that data streaming into the same table where it's historically available, then they just change their partition, the predicate on their query, and they just go back to last week on the same log.fastly table. And the way that we do this is we partition based on date stamp. And so we'll be streaming into today's partition, and that's where we stream in. And then at in our nightly batch, after the partition or the date is changed, we basically come back and we run a batch optimize on the previous day's partition. And so like there's lots of Delta magic going on in these tables. It's lots of fun. But that means that you've got really high performance queries on older partitions in the table, but you still have effectively up to the minute updates in that table. And that's the thing when we talk about streaming and sort of really empowering these ad hoc users or exploratory users, that's the thing that I think has really made a big difference, is that they don't actually know or have to care whether it's streamed or not. It's just, they just know the table that's going to have the data that they want in it.
And that actually makes a lot of sense, right? Because one of the key reasons Spark had built structured streaming in the first place, if I was to take the more marketing aspect of it, was things of saying you don't no longer had to think about streaming in order to be able to have streaming, right? That's why we built structured streaming, to have the structured context. And then with Delta, that took that one step further, because you could actually start finally decoupling latency from the business logic of actually running queries against that data. So your users, your product manager in this case, right, could go ahead and run the same query, whether it was meant to be a static table that was 6 hours later, or it was a dynamic table that was constantly was being updated with new data due to a streaming process. So that's pretty cool, because now you're just sort of showcasing that in action, basically.
So one of the things, I don't want us to get off on a tangent here, but one of the things for people to check out if they're really keen on streaming, with Delta Lake, Delta tables can be streaming syncs. So we sync data into it, but you can also treat them as a streaming source, which is really powerful for a lot of our batch or other live streaming workloads, where we will stream into one table from Kafka basically, and then data from there will get picked up by another stream just looking at Delta. So it simplified a lot of our streaming topologies just by saying, all right, once it hits the initial table, then we can just use that as the streaming source for anything downstream. Super cool use case, but I don't want to get too much off of our ad hoc topic with it.
No problem at all. But since you did open the door, let me actually call out two things. One is that Delta Lake 0.8 actually includes the ability to not just stream from using it as a stream source, but also stream from a particular time travel version or version of the data. So that way you can go back to it. You can start from a different version of time if you wanted to, not just from the current source, number one. And number two, exactly what Tyler's talking about. There's a lot of interesting CDC use cases. So there's that. So definitely take a look at that.
Mr. Lee, what does CDC mean to you? Centers for Disease Control?
No, in this case, though, you've definitely heard me talk about that in the COVID-19 set lectures, but no, in this case, change data capture. You're right. I should have definitely called that out. Thank you very much. All right, let's go. Now I'm just as guilty as you for taking us off course, so let's go back to our course. And you know what? We're going to bring it back to Alex, because Alex actually keeps us honest here. Okay, so let's talk a little bit about how Scribd had basically moved the development into the cloud environment and how to move to Databricks. And let's start specifically about the Spark Shell users, because I think we had chatted about this in the past, but why don't we elucidate a little bit about that on those Spark Shell users, what was going on before, and now what's it like working with them now?
Sure. So Spark Shell is a great tool, right? And if all you're trying to do is write some Spark in a shell, and that's about it. But unfortunately for us, we had too many Spark Shell users, and the reason for that is really we had two interfaces to our data for end users. We had Spark Shell and Hue, and our business analytics users, they would prefer Hue over Spark Shell. I can't blame them, right, for that. But Hue running Hive wasn't too fast, so we said, okay, let's have Impala. And sure, Impala is kind of fast, but oh, why is it giving me this weird data that doesn't actually match my Hive data? Well, because you got to keep the catalogs in sync. You have all sorts of things you have to do to get it to work right. So what would end up happening is that even our business users would end up running queries in Spark Shell. And the best part of this is, of course, troubleshooting. When somebody has an issue, guess what happens? It's a Slack message somewhere. Hey guys, I'm trying to run this query. So what are you trying to do? Oh, here is a blob of text from my Spark Shell. Oh, let me stare at this for a couple minutes. Oh yeah, it sounds like you. Oh, here it looks like you're doing something really weird. And oh yeah, try this instead. Oh, let me. Oh man, how do I paste this big text into back into Spark Shell? Oh man, this is horrible. Let me go learn to do that. And at the end of the day, it works. Oh, but now I'm having a performance issue. All right, let me go into my resource manager, try to find your Spark Shell here. Oh, now I'm going to get into your Spark UI and say, hey,
Alex,
oh,
I am loving this play-by-play. Just
yeah. Let me get into this Spark UI and look at it. Oh, okay, yeah, it looks like you're having some kind of skew problem here. Let me go research your data a little bit. Where can I research your data? Oh, that's right, in a Spark Shell. Let me go try to pull some basically data distribution metrics from your data in there. Anyway, so this is what we were doing, and
there were a lot more expletives in that process originally, just to be clear.
This is supposed to be a family-friendly show, I think, so that's why we're doing it this way.
Well, then I appreciate Alex omitting those.
So yeah, so at the end of the day, it was very productive, and when actually there was a conversation happening somewhere when we were just taking on this, before I think we even took on this big migration project to the cloud. We was like, hey guys, how can we make our users more productive? Can we get them all licensing for some kind of like development tools so they can? And my answer was like, we should at least try some kind of notebook solution for them, guys. Like, I mean, I used Zeppelin notebooks before, and that's not stellar, but even that is a much more productive development process than running around the Spark shells, right? So, and of course now we bring it to today when those users saw Databricks notebooks, it's like, oh, it's like, hey, why, like, you can do that, right? Why were we doing this other thing before? So, of course, it took us some time to get, we talked about data sync, to get data up into the cloud to enable those use cases. But once it was there, all of a sudden, our developers are loving it because they no longer have to use Spark Shell, even though you still can. When you're starting up your Databricks clusters, you still can set up your Spark Shell. And for the few users that we have that really miss it, I tell them, hey, you go do it. It's your thing. But in any event, it actually also changed the way we communicate, because now instead of having this long conversation in a Slack with lots of copy pasting, formatting, and staring at the code, you just get a notebook link saying, hey, I'm having this problem. Here, can you look at this? And in the notebook, I can see not just the line of code that's causing the problem. I can see the entire context, right? I see what they did before. I can query the current state of where they're in, right? And another good thing is that I can actually see the Spark UI right there and then without having to go dig for those things. And one thing that I've been encouraging our developers to use a lot is that, hey guys, you now actually have this ganglia right here, right next to you. Go use it. You see, you're abusing you're abusing our money resources. You're spinning up these huge clusters and you're not using them for anything. I'm gonna like slap you on your wrist for that. So, but with all seriousness, I think we just became much more productive. We no longer, because if you think about overall big data development, yes, you can write your jobs in whatever development tools you want to use. But at the end of the day, you have to run them against a realistic data set, which will most likely, even if it does fit on your computer, right? You still have to later on run it in the real environment to optimize it for the volume of data that you have, for any kind of data characteristics such as skew, etc., that you have to deal with, right? So now we have that ability. We have not just shell to do this. We have very powerful tools to do that.
No, that's completely awesome, Alex. And just for folks who are trying to provide the context, just since this is more of a discussion as opposed to us doing like a demo here for this series of sessions, this is very much the context of like, the embedded Spark UI and Ganglia all within the Databricks notebook environment. So this allows users to basically not need to pull up multiple different environments in order to be able to see the same information, just as Alex so loquaciously described, right? Instead, it's just all in this one little place, so it's really easy to find. And just as a quick tip for all you folks out there, don't forget to tag your resources as well, whether it's on the Databricks side or whichever cloud environment. So that way, as Alex called out, if you do need to slap people on the wrist, you have a better way to figure that out. All right, perfect. Well, I mean, this just really did a great job in terms of describing the jobs. But then, can we discuss or just talk a little bit more about now that you've moved the development into the cloud/Databricks environment, and we've also discussed a little bit about those exploratory use cases. What are some of the other use cases that we can probably dive into? And I think the first thing that we were thinking about was a little bit about the model training use cases. And so can we talk about how that worked, whether it's Tyler or Alex or Hamilton? I'm not sure who would like to dive into this first, actually.
For our old model training, so machine learning at Scribd is fairly tenured, I guess would be the word. I don't have the vocabulary that you do, Mr. Loquacious Lee over there. But we've been developing models for probably 3 or 4 years now that had to be trained on different sets of data and then launched into production and things like that. The way that people used to train models was more or less if they could shove it somehow into our nightly that was running in our on-premise infrastructure, maybe they could get their models trained there. There wasn't really a great opportunity for them to use our Hadoop infrastructure to train those models. But more often what I would see is I would see developers take data, take their training set that they would need, drop that into S3, and then they would go spin up GPU instances under their personal AWS account, do their training, download their model, upload that into where we were putting models at the time, and then file an expense report for whatever AWS GPU instances that they had used. So not great is what we were doing before. There was room for improvement. The approach that we've been able to enable thus far, and I want Hamilton to talk about how some of our clusters for these ad hoc use cases are set up. But what we've ended up doing is extending cluster create permissions to a number of the individuals on, say, the recommendations team or the applied research team or the search team that need to do their model training. And they'll just through Databricks, they'll just spin whatever beefy stuff up that they need in Databricks, and then they'll start training. There's definitely some things that can be, let's call it, interesting with training on Databricks, in that a lot of the types of models that folks are training, they can't take advantage of the distributed nature of a Spark cluster, but they still need Spark to access their Delta tables where they're sourcing their training set from. So when we're looking through the clusters list, we'll see these really like oversized, big beefy Trogdor arm type instances where it's like the biggest driver instance you can imagine, and then like this little bitty worker instance off to the side, because they're just spinning up a big massive driver instance to do their training on. We're hoping to find a little bit better of a way to do that. But right now it's pretty much, using Databricks as our portal into Delta Lake, but also just to give us on-demand GPU instances that are, tagged, have the right profiles associated, and all the other access controls that we need for that.
Okay, I do have to chime in. We'll definitely take this conversation on the side, but let's definitely have a discussion on whether it's Horvath Runner or Pandas UDF, so that way we're not doing the massively large cluster driver instances, and we can actually distribute it across multiple nodes.
Well, so we've had a lot of conversations about this lately internally on sort of what our model development needs are across the organization.
Okay.
And if you've ever read the children's book, If You Give a Mouse a Cookie, it is a very good parable of building a data platform for a data-focused business, in that you give them one thing and they want another, and then they want another, and then they want another. And so what we've actually found is just about every model training framework that exists, I could probably go find that internally. Because the way that a lot of the machine learning developers work is they'll try a couple of different frameworks and maybe build off some pre-existing models, and they'll experiment until they get something that looks like what they want. And that we certainly want to enable, but what that means for us from a like delivering tools and platform standpoint is we can't just say like, oh, here's the supported tool chain for you to go with. It has to be bring your own tool chain, just bring whatever you need. And so we have, part of the reason why we needed to grant these users the ability to launch clusters is so they could also install their own libraries into these clusters. And, bring whatever tools that they need without coming to talk to us about it.
Right. Got it. So it's from your perspective, it's very much this concept of self-service machine learning in essence, right? The ability for them to do whatever they need to take, and doesn't constantly involve basically pinging you guys here on every single potential library that they want to go play with, basically.
Yeah, and I think Hamilton can probably talk a little bit more about what we've needed to do to both manage self-service in that regard, but also try to keep some air of like supportability or manageability in our Databricks environment.
Perfect. Actually, that's a great segue. So Hamilton, yes, we were going to talk about this anyways, which was about how do you manage those shared cluster resources. So this is an excellent segue to, in terms of, for example, the ability for your machine learning engineers or data scientists to be able to go ahead and actually generate or build up whatever cluster resources that they need. So yeah, how do you manage it? How do you do it? I also alluded a little bit about tagging. So yeah, by all means, please dive into it.
Sure. I want to start off with like one of our biggest premises that we were focused on building around is the sanctity of what we consider our prod warehouse. So like the S3 bucket and glue catalog that we use to store what we consider production data has very limited write access, extremely limited, only accessible via various different automated jobs or the extreme like need to get in there with a manual touch every now and again for an incident or something. But through that, we have a number of different permissions and stuff set up so that different levels of access to that data, as well as different access to other catalogs, can be set up so that developers can go in and be able to write to a table without any chance of writing to production warehouse, but still be able to use the production warehouse data. So in order to do that, we had to set up a number of these cross-account IAM policies and roles that allow developers with their own AWS account for their team to create their own glue catalog and their own version of the same metastore that we use in the production warehouse, pointing to all the production data, and then be able to create their own tables pointing to their own S3 data so that they can start developing and working off of their jobs and testing, oh, I want this new job to create a new notebook. From there, we were able to have these different cluster setups with the different IAM profiles that are loaded into Databricks that allow them to get the particular access they need to the particular metastore catalog wherever they need, so that they can write scratch data all they want, and we don't have to ever worry about them causing an incident with like writing to production data or accidentally dropping a table that shouldn't have been dropped or something. They can just go crazy, delete what they want, don't delete what they want, and it's perfectly kosher for us. So from there, we granted a few of these users access to a couple of these individual roles where they can create any number of clusters with these roles, and it'll just work from a permission standpoint, and they'll have access to what they need.
Got it. That makes a ton of sense. So then, you've mentioned the process by which you've given, in essence, everybody access to these shared clusters, or shared resources, excuse me. But then I guess we're going a little backwards here, pun intended. Why don't we talk about what was it like before that, though? Right? Like, in other words, it seemed very straightforward to be able to talk about, like, okay, well, now everybody they can access the shared clusters. We have the right permissions, the right tagging. It almost seems quaint, like as in, oh, okay, here you go. But what was it like before? I mean, I think you don't have to go to the literal loquaciousness of Alex here in terms of describing, like, oh, I went to the Spark Shell, but nevertheless, it'd actually be good to know, like, what was it like from a resource utilization or from a in terms of how individuals had to go ahead and do this before, so they couldn't, for example, share the results of their data, or they had a hard time at least doing it, or they had a hard time having conversations about it because they weren't using a shared environment, and so forth and so forth. I guess if I was to talk about a theme, maybe the collaboration aspect of things.
Gotcha. So the big collaboration is the ability to have like those notebooks and be able to share, like, hey, this is what I worked on, this is how I got it, and here are the results from it, just in like a URL. Versus, hey, query this table and you'll see what I mean, probably, maybe. Additionally, like in our Hadoop environment, it was a little bit of the Wild West with like tables and stuff. People all were using the same metastore catalog there. So if someone was working on a table that they needed to develop, and while two people can work on the same like output table that someone was developing, right? Like I couldn't say, write a table with one of my jobs and drop that randomly if someone else was needing that data for something. So it was very difficult to kind of manage all these spinning plates of who needed access to what table. Hey, is anyone working with this? No, okay, I can go ahead and drop and change that. Additionally, in the Hadoop land, we were limited by the size of our cluster. So if some person wanted to hop on and run this massive like query and use like 60% of the cluster, well, suddenly now we're getting a bunch of messages saying, hey, is the cluster running slow for anyone else? We go in and we see Joe Schmo running like this 90% cluster utilization thing just because they forgot to use a partition predicate. And now they're querying against the entire historical data, causing all sorts of havoc there. So by
sounds like a bad thing.
Oh, you would have no idea how many incidents were caused by people just querying a lot of data. But by allowing some of our more power users the ability to like create clusters and with just the set permissions we want with proper tagging, we can just say, just spin up what you need, go wild. You won't affect our general users. You won't affect any of our nightly loads. You won't affect any of our actual other production use cases. You can just go crazy. You can crash it if you need to, and it won't affect anyone else.
No, that's I actually feel your pain completely on that one. I have had the environments where when I set up my own Hadoop environments, and what ended up happening was this gigantic, one person would run an errant query that would basically drain every single resource and then kick every single other person out or prevent them from even getting their results, let alone anything else. So yes, I definitely feel your pain on this one. So now, we've talked a little bit at the past, obviously, and let's go back a little bit more toward the future, the forward or to the future, right? It's my understanding, though, that you've actually done a lot of terraforming, actually, so that way for you to be able to manage all of these different resources together, so that way it's possible for you to be able to handle this idea of self-service yet also be shared at the exact same time. Like this idea that you can collaborate together, but without worrying that, or at least minimizing the chance that you take out everybody in the process. So I'm just curious, for those who may not know, what is terraforming from our perspective here, and then why don't you describe a little bit about the environments that you've done for Databricks and the cloud, for that matter?
Yeah. So in a nutshell, terraforming is basically infrastructure as code. So you basically say, I want this little piece of infrastructure. I want this piece of resource. I want this data structure in here. And you kind of like tie everything together and say, hey, go build me all these things in AWS, in Azure, or in some API endpoint, Databricks, for example. So what we do is we use Terraform to set up like all of the different users and profiles and other things that are available for use to access our production warehouse. And then also with Terraform, we are able to inject those into Databricks for users to use there. So basically, I don't have to know all the specific role that's there. I just say, hey, go build me a role in AWS and then go put it in Databricks. And then give this group access in Databricks. And it just is set up. I don't have to go in, manually set anything. If something changes, it changes all automatically throughout the system. So I don't have to really touch on anything there. So and if there's any sort of change that's needed, we have a Git repository with this Terraform that we can say, oh, here's when this line got changed. This is who changed it and why, et cetera, and we can go through the history of the entire instead of going, wait, who deleted this role? We can just go into the code and see, oh, this person deleted this for X reason. Or, oh, that was a mistake. Let's undo that and roll it back.
No, that's excellent stuff. So the I guess the call out theme I would go with here is basically we actually have metadata that now actually is in fact data, or at least configuration data, such that you can go ahead and have time travel on its own. In essence, code. In essence, we're treating it more closer to code now. So that way, we're able to roll back. We're able to deploy infrastructure from a CLI as opposed to busy clicking on 20,000 buttons to get to your point. So perfect.
Change management is the phrase I might use.
Oh, good. There we go. See, you're still loquacious, Tyler. All right. This has been really interesting, and I did want to end today's session actually to talk a little bit about what are some gotchas. We for the last three sessions, the last three sessions, including this one, we've talked about all the awesome benefits of like moving to the cloud, getting the batch jobs to the cloud, the process Scribd went ahead and did in order to be able to do it. But what are some gotchas that we might have missed that you'd like to call out? I mean,
we have plenty of gotchas. Would you like gotchas for ad hoc specifically, or gotchas for the migration to the cloud?
Actually, in this one, let's just focus on the gotchas for the ad hoc ones, if possible.
There's a very, very big gotcha that I think just about everybody should be aware of when you enable lots of ad hoc users in the cloud. The cloud is utilization-based billing. And so your users, you may not realize it when you enable them, but you're actually giving your users each a little bit of the credit card that they can just go spend and spend and spend. And so what we've done, there are cluster policies, which we've explored, but we haven't actually set in action yet. And that's a way to help manage this to a certain extent. You referenced tagging a bit earlier. We don't have. There are things on the AWS side that you can basically make tagging a requirement, or certain tags are a requirement. I don't remember if we actually rolled those out or not. We do have a pretty strong convention of tagging things, so that Hamilton's shaking his no. No, we didn't roll that out. We've definitely extended a lot of trust to people in the organization, and we're still a relatively small team. So we can certainly afford to extend some of that trust, but on the backside, someone like me, or some of the folks who are, let's say, passionate about cost management, do keep an eye on things to make sure that we're not, going overboard. That's probably the biggest thing. The other biggest thing, or other big gotcha that I did not expect, but I feel like I should have as we moved users into the cloud. Before, and our team was small enough, and the people who were accessing the data platform were all, let's call it intermediate to advanced in terms of skill set. We've now lowered the bar, but that means that there's a support burden, which is not necessarily a bad thing, but we've had to account for it on the data operations team and the core platform team and the data engineering team to a certain extent. There's time that we basically have to spend helping less familiar users understand the tools that they're working with, and whether that's documentation, meetup type things, internal meetup type things, or just pairing with somebody when they stumble or run into a problem. So it definitely became a very different dynamic to where, rather than giving, if someone on the data team, as it was then called, had a problem, we typically expected them to figure it out. Like, you're a smart person, you should know all of these pieces of technology that you're working with. Go figure it out. Like, you can't just stomp your feet and cry. You got to go figure that problem out. For a lot of our users now, and this is what Hamilton and I probably spend a fair bit of time throughout the week triaging and helping point people in the right direction, is you've got someone whose day-to-day job has very little to do with data, but they need this one piece in order to move forward, and they get caught up, or like, a transient error in the cloud, which of course happens, or a Databricks thing, like nodes disappeared and they got errors and they don't know what it means. Decipher this stack trace is something we do quite a bit. Now, Alex, I think it was our all hands at the end of the year last year. You talked a little bit about the support change and moving to notebooks at the all hands. Maybe you could talk a little bit about, just share some of the stuff that you shared at the end of 2020.
Yeah, then, well, I think we actually kind of covered this a little bit here, and that is support has definitely went up from the, I guess what Tyler is alluding to here. People got more brave and more adventurous, right? And yeah,
That's a nice way of phrasing it, by the way. Yes, let's go with brave and adventurous. Okay, got it. Go for it, please.
Alex is well known throughout Scribd for being diplomatic.
That's a good one. I'm gonna go with that one actually going forward. But I apologize. By all means, please continue.
They are brave and adventurous, but sometimes it's really us who have to deal with, I guess, the fallout of this bravery. And but it's actually a good thing, because previously the fallout would have been just so much worse, and that's why people weren't as brave, right? So this is what it gets down to. On the gotchas, one thing that we had to deal with is it's so easy to now create these auto-scaling clusters, right? It's just a piece of configuration. And another piece of configuration is like, oh yeah, here's my node mix-up. I want so many on-demand nodes versus so many spots. And then so many times we get this request, hey, why did my job fail? And you go look at it, it's like, well, because you ran out of spot instances, or your spot instances got decommissioned and somebody else. Like, well, why? Well, because you're in the cloud and you're competing with others for cheap hardware, so that's why. So I mean, if you're in the cloud, if you're gonna stay on the cheap side, you'll have some situations like this. Basically, is what I'm getting to. Maybe if you have very important workloads, which will take 2 days to run, whatever that is, right? Maybe don't be so greedy and get yourself a little bit more on-demand instances, so you don't have to rerun your job like 20 hours into it because you lost all your nodes. So yeah.
And I'd say the gotcha on my side of things was, in order for us to enable that really advanced bring your own catalog sort of thing, we had to get into quite the spiderweb network of cross-account IAM policies. So like we had clusters assuming roles in other accounts, which had access to a third account's resource, and had to make sure that the resources on every single side of that cross-account barrier had all the permissions set up for both ways. And debugging that can be quite a nightmare sometimes when someone says, hey, I'm expecting access and I just got a you're not allowed to touch this error. What's going on? And when we have to depack that, it is quite a tangled mess that we have to sort through occasionally.
it gets even worse when you have to get AWS support on this, because now you're like, oh, I know nothing about that account. I don't support that account. You need to get somebody in this other account to help us out to deal with this. Yeah. So.
No, guys, this is actually perfect. Not to knock AWS in the process, but this is a great way actually to finish today's session. I really thank you all taking time out of your really busy schedules to participate in today's session. Really, thank you very much and for all of you who are watching today's session. Hope you get to watch all three and get to learn a little bit more from everything Scribd has done to, well, upgrade themselves from legacy systems to the cloud.